So here we have to simplify some different roots. Now we have a couple cube roots and a fourth root. So the first one we have the cube root of 8. So we're looking for the cube root. But now since we're looking at cube roots, instead of looking for pairs when we split up the 8, we're looking for sets of 3. So let's split up 8. Well, that splits up into 2 and 4. 4 splits up into 2 and 2. Well, we have a group of 3. So I know that the cube root of 8 is 2. Now looking at the cube root of negative 8. Now since it is a odd power of 3, we are allowed to do this. So I split up the negative 8 into the negative 2, 2, and 2. I have a set of 2's, so that is equal to negative 2. Next we have the fourth root of 16. 16 can split up into 2 and 8, and 8 can split up into 2 and 4, and 4 can split up into 2 and 2. And since we were doing the fourth root, we're looking for a set of 4. Well, here we have 4 2's. So the fourth root of 16 is 2. So looking at the product and quotient rules of the nth root, it is the same thing as the square root. You are allowed to multiply numbers underneath roots. They have the same root. And you're allowed to do the reverse of that. And you're also allowed to split up the division in the reverse of that. So to simplify 6, the fourth root of 81, I'll split up 81. That splits up into 9 and 9. And I can split my 9's up into 3's. Well, I'm looking for a set of 4. Here I have 4 3's. So I can pull out a 3. So I have the 6 times 3, which is 18. Then I have the fifth root of 4 times the fifth root of 40. Now, if I split up 4, I'm not going to get a set of 5. So let's go ahead and multiply underneath my fifth root. Let it give me the fifth root of 40 times 4. Now let's go ahead and start splitting up. I can split 40 into 10 and 4, 4 into 2 and 2, and 10 into 5 and 2. And I can split my 4 into 2 and 2. We are doing a fifth root, so I'm looking for sets of 5. Well, here I have 5 2's. So my solution is 2 times the fifth root of 5. So here we have a huddle where you're going to be simplifying some radical expressions. Go ahead, pause your video, and when you're ready, unpause to get the solutions. I apologize, guys. The number 3, it should be the third root, or the cube root of 125 over 27. So go ahead, pause the video again, and work through it that way. My bad. So here are all the solutions. Again, I apologize for the bottom one, but go ahead and take a look at those. Here we have some more examples. We need to simplify the cube root of 64 over 27. So I can split this up into the cube root of 64 over the cube root of 27. So let's look at the factor tree of 64. And since I'm doing a cube root, I'm looking for sets of 3. Well, 64 is 8 and 8. And I can split each 8 up into 2's. So I'm looking for sets of 3, so there's a 2. Then I have another set of 2's. So root 64 is equal to 2 times 2. And let's take a look at root 27. So let's put 27 up, look for sets of 3. 27 is 3 by 3 by 3. So root 27 is 3, so we have 2 times 2 over 3, which is then just 4 over 3. And then for the next example, we have the cube root of 250 minus the 2 times the cube root of 16. Let's go ahead and split up 250. Well, 250 is 5 and 50 is 5 and 10, and 10 is 5 and 2. Since we're looking for sets of 3, these 3 5s will work. So that will be equal to 5 root 2. And then we also need to split up the 16, which is 2 times 8, and then 8 is 2 times 4, and then 2 times 2. There's a set of 2's, so that'll give me minus 2 root 2, which then is equal to 3 times the cube root of 2. I'm sorry, I forgot there was already a 2 out in front of the cube root of 16, making this 2 times 2 root 2, giving me 5 cube root 2 minus 4 cube root 2, which is equal to just the cube root of 2. So here we have a team huddle. Go ahead, pause the video, work through it, and whenever you're ready for the solution, unpause the video. So here is the solution to the huddle. It is 5 cube root of 3. So here we have the definition of a to the power of 1 over n. And it says if we have the nth root of a represents a real number where n is greater than or equal to 2, then the a to the power of 1 over n is equal to the nth root of a. So the denominator of the exponent is the radical's index. So for example, if we have something like x to the power of 1/2, that's the same thing as the square root of x. So if you have a to the power of negative 1 over n, and then again a negative exponent will make our flat fraction flip, so we will go down in the denominator. We'll give 1 over root the nth root of a. And again, the denominator of my power tells me the root. So if we have a to the power of m over n, this lets us know that we still take the nth root of a. So right here we have a to the power of m over n. We take the nth root of a, but that is to the power of m. So if I have something like x to the power of 2/3, I take the cube root of x all to the power of 2. And again, the negative exponent is again going to flip our fraction and make whatever's in the numerator to the denominator. So here we have the example of 81 to the power of 3 over 4. And this will be equal to the 4th root of 81 to the power of 3. Or the 4th root of 81 all to the power of 3. Either one you can work with. Personally, I prefer to work with the second one, so let's go ahead and split up the 81, looking for sets of 4. So 81 is 9 times 9. The 9's going to split up into 3's. There's my set of 4. So I have 3 to the power of 3, which is 27. The next one I have 32 to the power of 3 over 5. Well, that can give me 32 to the power of 3. And then I take the 5th root of that. Or I can take the 5th root of 32 all to the power of 3. Again, I prefer the second one, so let's split up 32, look for a set of 5. 32 is 8 and 4. 4 is 2 and 2. And then 8 is 2 times 2 times 2. Looking for a set of 5. Here's a set of 5. So I have 2 to the power of 3, which is just 8. And last but not least, we have 48x to the power of 5 over 3 over 3x to the power of 1/2. The first thing I do, I can split up. This is 48 over 3 times x to the power of 5/3 over x to the power of 1/2. Well, 48 over 3 is just 16. So 16 times whatever x to the power of 5 over 3 minus 1/2 is. Well, since I know I'm dividing these bases with exponents, I know I will subtract my exponent. So it's times x to the power of 5/3 minus 1/2. Well, 5/3 minus 1/2 is 7/6. So my final answer will be 16x to the power of 7/6. So that sets us up for the huddle. So go ahead, pause the video, and whenever you're finished, go ahead, unpause it to get your solution. So here are the solutions to the huddle problems. The first one is 5. The second one does not exist because you're taking the even root of a negative number, which we learned earlier that does not exist. And number 3, that one will work because we have an odd power, so we can take the odd roots of anything. And when that's simplified, it is 1 over negative 3, so negative 1/3. So that sets you up for the homework. Your homework is on page 43, 45 through 100 multiples of 5. Good luck, and thanks for tuning in.